All right, welcome back. We're going to look at our next factor, catalysts. Catalysts are just substances that will increase reaction rate by lowering the needed activation energy. So they don't supply more energy to a reaction, but what they do is they kind of lower the cost. So energy, do they add or decrease energy? No, they don't. They just lower the cost. Change orientation? Nope. Do they change the number of collisions in a second? No, they don't. So when we think about why does having a catalyst speed up a reaction, it lowers the activation energy needed. So it lowers the activation energy needed, it doesn't give more energy. And it doesn't affect the orientation or the numbers of collisions. So since every collision needs less energy, more of them are likely to happen in a given amount of time. Pressure. Pressure is focused on gases. So higher pressure, you get a faster rate. Higher pressure, the reaction forces the gas particles closer together. It therefore kind of like increases the concentration, brings them closer together. So you get more frequent collisions. So in a pressure cooker, this pushes the particles closer together, therefore is able to react faster. So higher pressure, does it change the amount of energy? No. Does it change the orientation? No. Does it change the number of collisions in a second? Yes. It does this by bringing them closer together. So let's think about lower. Energy and orientation? No effect. If we have a lower amount of pressure, meaning that particles are more spread out, then that's going to decrease the number of collisions. So why does lower pressure cause a reaction to move slower? Since the particles are at lower pressure, they're further apart, meaning they collide less often, therefore have less opportunity to have a successful reaction with enough activation energy and orientation. Let's look at our last factor, which actually seems kind of funny-ish, maybe think of it as the first, but it's the nature of the reactants themselves. So some things that are all by themselves. So some substances are naturally more reactive than others due to their chemical structure and bond types. So what things it might change kind of is energy, orientation, number of collisions, but it's actually just thinking about these different parts. So the chemical itself. Some elements lose or gain electrons more easily. We talked about this with ionization energy and electron affinity long ago. For example, potassium reacts explosively in water, while gold, painting for gold, doesn't react at all. So based upon their atomic structure, that might change the amount of energy required to react. Secondly, bond type. Reactions involving ionic compounds like mixing solutions are often instant because ions are already free to move and link up and produce a reaction. Reactions involving covalent compounds are solid often because these bonds need to be broken first in order to react. They won't react until those bonds are broken, so that takes more energy in order to occur. Lastly, bond strength. Weaker bonds require less energy to break, leading to faster reactions. Things like crazy glue have very strong bonds, so they would react very slowly to come across and break apart into their other products. So all of these concepts here are trying to get the idea that the nature of reactants can have a pretty big impact because they might require less energy to react or more energy to react. Things like orientation and number of collisions per second generally are not affected by these ideas. As far as our final joke, I was going to tell you a joke about chemical kinetics, but I didn't have enough activation energy to get a reaction. Be sure to answer the final question so you can come in with the great understanding that we're looking to build upon. See you soon.